In this video, I would like to explain one of the algorithms we use a lot in data mining called clustering. To explain a concept of clustering, we'll use a customer's data available in Chapter 7's database. Okay, so let's take a look at this table. So this table has a lot of data, age, education level, gender, home ownership, marital status, and so on. So what we'd like to do is I would like to have a subgroups out of this population so that we can use each group for various purposes, such as marketing. Okay, so let's take a look at how many data points are there. So we have a 3,000 customer data points. Okay, so all right. So let's go to a Visual Studio as usual. So go to a Visual Studio and open that. Okay, and that access your database using Analysis Services database. Okay, and then you should have a Solution Explorer like this. Okay, if you are not familiar with this routine, why don't you look at the previous the videos. Okay, as usual, we need to create a data source for Chapter 7, which we actually did. So if you haven't done it, why don't you do it? So create a data source. Okay, and after that, we need to create a data source view for Chapter 7. Again, we actually did previously, but if you don't have it, why don't you create it again? All right, so let's go to a mining structure. Right mouse button, new mining structure. Okay, next. Yes, we're going to use a existing relational database. Okay, and we'll use a clustering algorithm, the second one in the list. Okay, next, and we're going to use a Chapter 7 data source view, which includes a customers. Okay, next. All right, we will use only customers. Okay, so let's use customers as our case, and these are the attributes or columns in the table. So we'll use a customer ID as a key. All right. As an input, we need some attributes of age, education level, gender, marital status, number of children. Or you can choose more or less depending on your domain problem. All right, let's just do that. So we chose a age, education level, gender, and marital status, and the number of children. All right, next. So make sure data type's okay. So age is an integer, so long, okay. Text, number of children, also integer, so that's fine. All right, next. So let's use a 30% for testing, that's fine. So our structure name, this is actually Chapter 9, even though we are using Chapter 7 database, actually the same data table anyway. So Chapter 9, customer table, mining structure. Okay, so we're gonna do a customers analysis using clustering. Okay, and we'll allow the read through so that we'll be able to see the individual data point later. Okay, so finish. Cool. So we have data available here. So let's go to a mining model and see how it goes. So we had a customer ID as a key, and the age is age, education level, gender, marital status, and number of children as input. Okay, sounds cool. So let's process it. Okay, run. Close, close. So everything seems fine. So let's take a look. So we have now 10 clusters. By the way, you can always choose a different number of clusters if you want to. To do that, just go back to a mining model and choose the data mining algorithm, and then go to properties, and then can you see the algorithm? And then also one of them says algorithm parameters. Okay, you can go there. Can you see that? Dot dot dot. So click that. So you can always change a cluster count if you want to. And the default is 10 right now. Okay, so let's use the default here. Cancel it. Okay, let's go back to our viewer again. So these shows the relationships among those clusters. Okay, so let's take a look at the profiles. So if you look at one, let's make it so we can have profiles for cluster 1, 2, 3, 4, and so on. And also you can see characteristics. So if you look at so let's look at cluster 1. So cluster 1 is a pretty young male single type people. Okay. If you look at cluster 2, it's a more married male or like with a bachelor degree. So anyhow, so you need to check the characteristics of each group, and you may want to give a good name, okay, rather than something like cluster 1. Okay, that's not cool, right? So let's give a name. The right mouse button. Can you see that? Rename cluster. Okay, so have young male singles, something like that. So you can choose whatever you want. So you may want to do the same thing for other groups. Okay, so you can see a cluster profiles. Okay, and also you can see characteristics. Also you can see a discrimination between different clusters. Okay, for example, how about cluster 1, which is a young male singles, and how about cluster 2? So you can clearly see the difference. So the first one, the young male single group, most of them never married. Cluster 2 are married. Okay, so you can see the different groups with the different characteristics. Okay, let's go to our prediction. Okay, and we need to select the model, but there's only one model we are going to use anyway. So chapter 9 customer thing. So if you don't do anything, this is the one we're going to use anyway. Alright, so we're going to use a singleton query. Okay, of age of 25. Okay, education level, just graduated from college. How about bachelor degree? Gender, how about male? Marital status, how about single, never married? Number of children, how about 0? Okay. Okay, now we want to know what group this person may belong to. Okay. So cluster. So let's take a look. So this guy probably belongs to a young males or singles. Okay. But probably you may want to know how confident you are about this clustering. Okay, so we need some probability. Sure. So let's go to our prediction function of cluster probability. Okay, and we may want to give us some name so that we see what the number is later. Okay, and cluster, we need to have to say what we want. So cluster, open parentheses, and close parentheses. Alright, so the cluster is a young male single, and the probability is about 90%. So, pretty good. Alright, but this guy actually may belong to different groups or different clusters. Sure, so let's take a look. What are the probabilities of this person belonging to different clusters? Okay. Prediction function. Okay. So how about histogram? Can you see that? Predict histogram. Okay. Let's give an alias for this column so that we can understand what it means later. Okay. So histogram. Okay. And the cluster column reference. So cluster, open parentheses, and close parentheses. Okay. Let's run. Okay, so this person belongs to a young male singles cluster with a 90% of probability. And if you open this plus sign, and then we actually see this person may belong to a cluster 4 with a 8.5%, so that's dramatically low. And cluster 2 may be 0.7%, so very unlikely. So you can see, any possibilities of this person belonging to other clusters. Okay. The clustering algorithm we are talking about here, obviously very useful for making subgroups out of a huge population. But also at the same time, another purpose we are using this algorithm is for anomaly detection. Sometimes some data may be totally outliers, okay? And those outliers can be the result of fraud or mistakes or whatever. So it may be a good idea to check whether a certain data point is an anomaly or not. Okay. All right. So let's take a look. How about number of children over here? Let's change it to how about 100? And that's too dramatic. How about 20? So as a single person with the age of 25, having 20 children doesn't sound really right. Okay. So let's take a look. All right. So let's go to our prediction function. And one of the function is a can you see that? Let me make it a little wider. One of them is a can you see the predict case likelihood? Predict case likelihood. Okay. And how about we can give a name like anomaly detection. Okay. So if you do not do anything, they will use a normalized option anyway. So let's take a look. Okay, so cluster 9 with some same kind of probability we just talked about. Okay, and look at this anomaly detection. This person belonging to cluster 9 is a just infinitesimal. This is a 0.0000000 1 something, so practically 0. Okay, so we know this data is a very much anomaly, even though this person is probably, if you have to allocate this person to a group, it may be cluster 9, but even in cluster 9, this person is likely in cluster 9 is practically 0. Okay, so how about let's go back to our initial data, 0, and see how it goes. Okay. All right, so in this case, the person belongs to a young male single, and if you look at our anomaly detection, actually 0.996, so 99% this data is very likely. So we don't think that this is any anomaly data in this case. Okay, but when you change this to a very unlikely number, obviously this algorithm detected it, and then we can do any actions based upon that recommendation. All right, so it should be fun to review this. I'll see you later. Bye.